going down. Welcome to the Space Jam. It's your chance, do your dance at the Space Jam. Alright.
Oh, my goodness. I didn't see you there. Sorry, I was listening to some Space Jam. Is anyone else in the room? Can I talk in my normal voice? Okay, welcome back, boys and girls, to your last PowerPoint presentation on converting small numbers in standard form in our scientific notation unit. So I want you to look at this purple square. Well, actually violet. Currently, in order for you to see violet, it's giving off a certain wavelength. In science, the wavelength is measured in meters of violet light, not red light, darn it, is 4 times 10 to the negative 7th power. So 4 times 10 to the negative 7th power is written in scientific notation. In order to convert it from scientific notation to standard form, this is what the number would look like. When you go from scientific notation with very, very small numbers to standard form, you move the decimal place to the left, the number of spaces given by the exponent. So 4, when you look at 4 here, the decimal point is located after the 4. So when we move the decimal to the left 7 spaces, we go 1, 2, 3, 4, 5, 6, 7. I fill in those extra spaces with zeros. They represent placeholders. So when the exponent is negative, you move the decimal to the left. A negative exponent symbolizes that's a very, very small number. So for example, 3.43 times 10 to the negative 7th power. The negative 7 represents how many times you move the decimal. So in this example here, my decimal point would be located between the 3 and the 4. So I'm going to move it to the left 7 times. I count the 3 as 1, 2, 3, 4, 5, 6, 7. I end up plugging in 6 zeros as placeholders. So let's do a couple examples, and I'll give you some strategies that you can use. Okay, in this example, I like to write down the numbers that are being multiplied by the base 10. So 267, which is also my area code. So 2.67, I need to move my decimal point to the left 5 times. So 1, 2, 3, 4, 5. To the left 5 times. I'm not sure if I said 5 or 7. My alien brain doesn't work sometimes. So 2.67 times 10 to the negative 5th power would be 0.00000267. Okay, let's look at another example. 8.436. Again, I like to write my digits down first. And I'm going to move my decimal to the left 7 times. So if my decimal point is here, I have to go 1 and fill in the rest with zeros. 2, 3, 4, 5, 6, 7. Decimal point. Okay, let's look at another example.
Welcome to the Fosdick Flip Classroom Freeze. Lincoln and I have been walking for about 42 minutes because he literally stops to look at everything. On the back of your graphic organizer, I want you to convert 42 minutes to seconds. Oh, here we go again.
Okay, let's look at another example. 4.5 times 10 to the negative third power. Again, I'm going to write down my digits, 4 and 5. My decimal point is here, so I have to move it to the left 3 times. 1, 2, 3. I'm going to put my decimal point. And why don't we do one more example? 3.78 times 10 to the negative 6th power. I'm going to write down my digits. Move it to the left 6 times. 1, 2, 3, 4, 5, 6. Okay, what I want you to do is get out your graphic organizer. We're going to fill in our last section. Where are my ink tools? Okay, so when you have a negative exponent, means it's a very, very small number. You're going to move the decimal to the left. So here are my digits, 7.723. That's a little too much. I'm going to move it to the left 4 times. 1, 2, 3, 4. And then put my decimal point. You have officially completed the scientific notation concepts. Now we're going to apply the rest to real world application. And since you're watching this video on the weekend, why don't you get up and start dancing because you did your homework. Good for you. Thank you very much. Miss Fosdick will appreciate that.
Let's get ready to rumble! Y'all ready for this?
No more copyright here. Bye, Earthlings.